Hey guys, welcome to lecture 22. In this lecture we're going to be going over some summary statistics. Sorry. Pandas comes with some really good methods you can call on data frames. They're all built in, and you can summarize data in these method frames. So let's go ahead and start off with importing NumPy as NP. Basically our usual stuff, importing from pandas, import series and data frame, and then import pandas as PD. Awesome. First off, what we're going to want to do is create a data frame to work with, and I'm going to construct this data frame from a matrix that I built using np.array, like we've done in the past before. Let's go ahead and make this a 2x3 matrix. So the first row, I'm going to give it 1, 2, and then I'm going to do something a little different that we haven't seen in the past before. I'm going to make the third value np.nan, so I'm going to make it a null value, and you'll see why I do that later. And then same thing for the first value in the second row. It's also going to be nan, and then I'll give it some numbers there. So let's go ahead and make that matrix. And now to build my data frame, we'll call it dframe1. I'll pass the matrix I just made. We'll give it an index. Index will be AB. And the columns, we'll call them 1, 2, and 3. Alright, let's see what that looks like. So, for my matrix, that was 1, 2, null, null, 3, 4. Now we have it in a data frame with A and B index, and the columns are called 1, 2, and 3. Cool. So let's see the sum method in action here. Just take a look at what happens. So what is this going to do? So sum on a data frame, it's going to sum up all the values for each column. So for instance, the 2 column, 2 plus 3 is 5. And you notice something that's really nice about pandas when you're calling sum. It's going to ignore null values, so it's not going to crash on you just because you have null values there. It's going to be able to just ignore them and treat them as zeros, so it's just going to skip them over. Okay. What if we wanted to add up the rows? Well, you can do it the exact same way. You just got to indicate that your axis is 1, and now you've summed up the rows instead. So row A, 1 plus 2 is 3, and then row B, you have 3 plus 4 equals 7. Cool. What other methods can you call on a data frame? Well, you can call the min method on a data frame. And what is that going to do? Let's take a look at our data frame again just to get a picture. The min method is going to find the minimum value in each column. So with the 1 column, the 2 column, 3 column, the minimum value, if we take a look at the 2 column, it was 2. Since it's comparing 2 and 3, 2 is the smaller number there, so 2 was the minimum value. So it returns the 1, 2, and 4 values there, the minimum values for each column. What if you wanted to find the index of the minimum value in each column? There's a method we can pass there as well. In that case, it's just going to be idxmin, and that's going to give you the index of each of those minimum values. So if we take a look back at the minimum values that were 1, 2, and 4, which index were they in? So the 1 column, its minimum value is 1, and if we look back at our data frame, the index for that value is A. So A is the index of the minimum column or the minimum value for column 1. Let's go ahead and look at column 2. What was its minimum value? Its minimum value was 2, and the index for that minimum value was A. And then finally, column 3, its minimum value was 4, and the index for that one was B. And so IDX min will return the index of the minimum values in each column. All right. You can do the same thing with finding the maximum values. They're the exact same methods, but instead of writing min, you just write max. So let's go ahead and see our data frame one more time. 1, 2, null, null, 3, 4. We can also do an accumulation sum if you wanted to. The way to do that, it's really easy. Just come sum, call it on. Whoops. Remember we called it dframe1. Go ahead and pass that. And now you have the accumulation sum along the columns. So the only place you're going to see the difference there is in column 2, where column 2 index B, its value is now 5. Since the accumulation sum was 2 plus 3, it changes that value to 5. Cool. So now that we've gone over some basic methods, let's get into the real useful features of pandas. So one of the most useful features is something, a method called describe. Let's go ahead and just see what that looks like. So if we call describe method, I'm sorry, there we go, dframe1. So what does describe do? So describe is going to provide summary statistics for your data frame. So it's going to give you a bunch of statistics on your data frame. It's going to count how many objects you have. Going to give you this mean, the standard deviation, other statistics to find values within certain distributions or probabilities beyond the mean. And you can get that all just by passing describe. Cool. So speaking of statistics, what else can we get? We can also get information. We can get information on the correlation and covariance of your data in your data frames. So what I'm going to do now is from ipython.display, I'm going to import YouTube video. And this is going to allow me to actually show you some YouTube videos. So in case you're feeling, if you feel like you need a refresher on covariance and correlation, or you just want to just learn a little more statistics, since you're going to need to understand covariance correlation for the rest of this lecture, there's some really, really great videos on YouTube, the best sources on the internet that I found for learning basic statistics. And I'm going to go ahead and put the links here so you can see it. And again, you can just grab these from the IPython viewer notebooks on GitHub. So this first video, this is for understanding covariance. The videos are made by a man named Brandon Foltz. They're really, really great videos. And the second video is on understanding correlation. So go ahead and check out these videos if you're feeling not so fresh on covariance and correlation. So, and then once you've gone over these two videos, you can come back to this lecture and learn how you can find the correlation and covariance on values in your pandas data frame. Okay, so now that you understand covariance and correlation, let's go ahead and make a data frame, get some information. So what kind of information do we want? It might be interesting to see correlation and covariance on some stock prices. So in order to do that, we can actually use pandas to get information off the web. We're going to learn how to do this in much more detail later, so that you can think of this kind of as a sneak peek of what you're going to learn in the future. So what I'm going to do first is import pandas.io.data as pdweb. This is going to allow us to get some information off the web. Then I'm also going to import datetime, just a pandas library for date input. and then I'm going to create a data frame called prices. Well, let me import these first, make sure I didn't make a mistake. Perfect. So what can we do to get some prices? Well, we'll call pdweb, and then we're going to call get underscore data Yahoo. So there's a lot of built-in methods to get stock prices automatically from the web. And all you got to do is input symbols, the dates you want them for, and then what kind of values you want off the stock. You can also get it off Google Stocks and various other sources. We'll be learning about this much more in detail later on. So this is kind of just a preview. So for correlation and covariance, let's go ahead and check out maybe some oil companies. So I'm going to put some stock symbols for oil companies such as ExxonMobil or British Petroleum. These are some of the largest corporations in the world, so it should be interesting to see their stock price data. And we'll say the start, this is where we're going to use date time. So I'm going to start it from 2010, January 1st. And I'm going to end datetime. And let's end it just 3 years later, so 2013, January 1st. And then the value I want off of this is the closing price, which in this case is going to have to be pass the string ADJ space close. Alright, and again, don't worry, we'll be going over this in much more detail in the future. This is kind of just a sneak peek on how to get information, financial information off the web. Let's see if this worked. Alright, took a little bit, but it got it. Prices.head. So .head just allows you to see almost like a preview of your data frame. So it's just going to show you the first couple values. So we have our 3 stock tickers symbols as the columns, and then the date as the index, and the actual stock price. So now we have a data frame full of stock prices, so that's pretty awesome. Let's go ahead and get the volume of the trades. So in order to do that, I'll do something really similar. I'm going to say pdweb.get underscore data underscore Yahoo. We'll pass the same ticker marks, the symbols. Whoops. And let's capitalize that X. And we'll do it for the same time frame. So the start time frame will be datetime 2010-11, and we'll have, whoops, forgot to put the day. We'll have the end be datetime 2013-11. And in this case, what I'm going to call for is the volume. Last time we called the closing price, this time I'm going to ask for the volume. And it looks like I messed up some syntax, and what I forgot was a comma to separate the start and the end. Let's try that again. Okay, and let's go ahead and just use the method head to see the head of that data frame. Just get a preview. Cool. So this is the amount of stocks that were traded on each of those days. So the total volume of stocks. So what would your return be? So the return would be the percentage change in prices in your stocks. So let's go ahead and call an object rets for returns. And then from your prices data frame, the method you can call is %change. So now you have the returns on your stock. And let's say you wanted to get the correlation of the stocks. How would you do that? Well, we can set another object, and we'll say we can pass the correlation argument, which is .corr, on that new returns object that we made by getting the percent change on the prices data frame. Let's run that and see if that works. Awesome, it did. So let's just get a rough idea of what these prices look like. So in order to do that, I'm just going to call plot method on this data frame, prices. And again, in the future we'll learn a lot more about all this. This is just to get you a little taste of the correlation and covariance. So it's going to plot that from prices. Okay, so notice that I didn't actually see the plot. If I want to see the plot, I have to call a special command. We've seen this in the past. We've got to call matplotlib inline. So let's try that again. Alright, awesome. So now I'm actually seeing the price of each stock, and you can kind of see how they relate to one another, especially the tickers CVX and XOM. You can see that they're really correlated to each other, especially around maybe September 2011. There's a dip, and then the rises seem to be really similar. The British Petroleum stock, it doesn't seem to be as quite high of a correlation, but there's still definitely some correlation there, just not as close as the CVX XOM. So what if you wanted to plot out this correlation? Well, again, here's another sneak peek at what we're going to be learning in the future. We're going to import Seaborn as SNS, and I'll go over this in much more detail later, but Seaborn is going to be a plotting library to help us visualize some data. And then I'm going to import matplotlib.pyplot as PLT. And let's go ahead and import those two. Let's see how they work. And now we can use Seaborn SNS to make a correlation plot. And Seaborn can do that just by passing corrplot. What we're going to want to do is get the data. So if you remember before, we have our returns data set as the object RETS. That was just a percentage change in prices. I'm going to set annotation as false so we get a clearer picture. And I'm also going to set diagonal names as false. And this is just to make a clearer picture, but we'll have a whole section on learning Seaborn in the future. We're going to learn a lot about it. It's going to make some really great plots. This is just to give you a preview of what that looks like. And here you have a really nice plot here, and it's actually showing you the correlations between them. So it looks like XOM and CVX have a really high correlation, 0.8. That's pretty high. And if we look up here to the actual prices, that really makes sense. If you see, they're really correlate with each other. When one goes up, one goes down. I mean, these curves look very similar. And that shows in the correlation data as well. So awesome. So now you've seen it visualized, one kind of in the back of your mind. You can see how this would be highly correlated. And then mathematically, you've actually done the correlation, seen that it has numerical values to it. And then last thing we can do after that preview, let's get back a little more on track to stuff we want to learn right now. We can check for unique values and their counts. So in order to do that, I'm just going to make a quick series. And let's just make this, let's just have it be a bunch of letters. So I'll say WW throw in an X, throw in a Y, throw in a Z, throw in another W, and just a couple more letters just so we get a good feel for this. And then finally I'll put an A at the end, something unique. I'll show the series, and whoops, sorry. I should be passing a list into the series, so we need those brackets there. Let's go ahead and see what it looks like. Alright, so you got your series, bunch of letters. If we wanted to grab the unique values, I can do that by passing the unique method. And now I get an array return with each of the unique values. So W, X, Y, Z, A were all the unique values. What if I wanted to know how many of each of the unique values there were? I can say value counts. And now I know how many W's, X's, Y's, A's, and Z's there were. Okay. That's it for summary statistics. Next, we're going to learn how to deal with missing data. Let's just quickly scroll up and see what we learned. So the important takeaways here are learning how to call different summary methods onto a data frame, such as .sum, .min, or .idxmin, or .idxmax, or calling min. Really useful feature. The main thing you get out of this, describe. Describe is super powerful, and we'll be using it quite a bit throughout this course. To give you a little taste of the future, we went over covariance and correlation, and how we can grab information off the web using pandas, just to give you a little taste of what you can really do some amazing stuff with pandas. And then how we can plot, and how we can make really good looking data visualization plots using Seaborn, which we'll learn about Seaborn and plotting in the whole other section on data visualization. Alright, awesome. And then we can check for unique values in a series or data frame, and we can also get their value counts. Cool, so that was summary statistics. I'll see you on lecture 23. Thanks.